Hi, hello, welcome to my channel. I'm Ravi Kumar. In this video, we are going to learn about compilers. So what are compilers, how compiler works, and how the compiler translate normal text to object files, right? So let's get started. I'll go to Visual Studio. I have written some code here. So what are we trying to understand here? We are writing some text in text editor and expecting it to understand by computer, right? We are expecting this code to be understood by computer. So for that, C++ has created a program to translate our text file, which is written in English, to machine code, which is zeros and ones. So in other words, compiler is a translation program provided by C++ to convert a human readable language English to a binary code, which is zeros and ones. Computers only understand a binary language, it will not understand English language, right? This CPP file is also called as a translation unit. Compiler really doesn't care about .cpp extension files. It only cares about the input. The input can be given in any format, but C++ has defaultly taken a CPP extension as its format and start using it. You can also give a .x extension, but you have to tell the compiler, please treat this as a input file for compilation, right? Before compiling anything, compiler has one other job to do, which is pre-processing the statements, right? Anything that starts with hash is considered as a pre-processing statement in C++. So what are these pre-processor statements and how does this work? Let's see that in action. Just ignore what I have written here. I'll just say outline. I have written line number 3 for making line number 7 validate. Okay, if I remove this line number 3, my line number 7 will not work. Okay, so I have put line number 3 to help line number 7 to validate. Okay, I have written this hash include IO stream validate my line number 9. Let's see, line number 9 is now invalid for the compiler. What it says is namespace std has not mentioned in cn. So this is how the compiler treats our code based on what we write. Now, what is this hash include? We are trying to understand this hash include, right? Hash include means it is literally include whatever the content which is available in IO stream to this current text file. Let me show this with an example. I have written this void print const char output, right? I'll write this line in some other file. I'll write this line in this file. Okay, now I'll just include this file in my source file. Now the print is invalid, right? So why don't I hash include? I'm including the file which is having that functionality .h. print.h is the file name, right? Once I put this, my error is gone, right? What does that means? Whatever the name we are providing inside the include will be copy pasting, literally copied and pasted here, and that is how the error got gone. So these are the pre-processing statements, and what this pre-processing statements do is just simply copy the content in the file and paste it in here so that our current CPP file get knowledge on what the file is about. So we have a lot of pre-processing statements here, include, define, if and f pragma. These are condition compilation macros. So we can also provide some conditions during compilation. We'll see about this in later video. We'll just concentrate on how the compiler works, right? Let's see one more example with hash, that is define, hash define. What you are seeing here is I have defined sprint with output, okay, and I'm replacing this with my output. Still works, right? So that means whatever I have written after the define is replaced with print, and the compiler is allowing it. That means the compiler is pre-processing the print functionalities and putting that information in output. It doesn't make convincing, right? Let's see in action. Visual Studio provided some ways for us to see how the pre-processing has done. Okay, let's see that. Right click on the project, go to properties, go to C++, go to pre-process, If you set this to yes, the object files will not be created. If you see here, a definition is given that says object file will not be created if this set to yes. So after practicing this example, don't forget to change it back to no. Okay, I'll say this yes. Once I put this yes, I'm cleaning this. I'm going to File Explorer and see and debug. I don't see any .i file, right? Now I'll compile this. I have compiled. Going back to the same folder. If you can see, there is a .i extension file is created. Let me open this in Notepad. A huge number of lines got pre-processed because of IO stream. We'll get that to later. We'll see our hash defined first. Okay. So this is how our file got converted. We have written something and we see something here. What we have written is output hello world, but what we see here is print. Does it make sense now? So the output is replaced with print. That is what the define is doing. Okay, this define is replacing output with print. Even though I put output for my convenience here, it got replaced with print internally and then it got compiled. We have three pre-processing statements here. We have seen for print. Also we have two other. I'll see for hash include print.h. In my file, it is hash include print.h. Actually, what is there in print.h is this void print const char output, right? The same thing you will see replaced in our source.cpp. See, if you can see line number 203, the print.h is replaced with the content, right? The same way, this IO stream is having very huge functionalities it have, right? These functionalities got included here. All these functionalities are IO stream functionalities. That is why our file size is very big. See, 1562. If I compile some other file, .h files will not be compiled. As I said, CPP files are translation units. Only translations unit will be compiled. If I go here, I don't see compilation symbol. The compilation symbol is inactive, right? If I go to print.cpp file, the compilation symbol got activated. That means this will allow us to compile, but this not. Created a CPP file in which I have a function. It doesn't have any pre-processing statements. Okay, let's compile this and see the I file what it contains. I'm compiling. Going back to the folder, addition.i file got created. My CPP file is .cpp. For this, a pre-processing file got created, that is with extension of I, which is this addition.h. See, it has only 1 KB because it doesn't have any pre-processed statements. Let's open this and see what is there inside. See, you don't have anything. You have line 1, you don't have any pre-processing, you have addition, int, return, right? That's all. Okay, let me add one more pre-processing statement here and see how it reflects here. Hash include print.h. I'll compile this and I'll see it in the file. The hash include print.h got replaced with this function. What do we have in hash include print.h? We have this. And what we got here? The same thing we got. You write something else here, like we save this and then again you compile this. Go back to the int ab we got here. We are just including a single line of hash include print.h, but whatever the content inside it is getting copied into the file, right? This how many lines I write here, every line will be printed. I'll compile this addition.cpp. It is asking me to update the file. Yes, see, everything got updated here. The same thing happened for source.i. Every functionality in IO stream got appended in here. Every IOStream operation got appended here. All these are IOStream operations, right? I'll remove all this garbage. I'll save this and I'll compile one last time. And we'll see this. Okay, everything got replaced. I'm including print.h, but we are getting what are the functionalities inside the print.h. They are appending into the current source file. That means it is literally copy pasting every content inside the print.h and putting in it. The same happens for source. Every content inside IOStream is copied and put on the same source file so that it can compile without any problem. Let's go to this folder and see the file size of this. If you can see, we have IOStream on this, that's why it is 1562 KB, and if you see here we have only 1 KB because we don't have any huge headers included in edition.i. So this is how the pre-processing is done in C++. So far we have seen how the pre-processing is done in C++. Now let's see how this is getting converted into object file. Okay, how our instructions are actually converting into an object file. For that we have to go back to this properties and we have set this to preprocessor, right? We need an object file to see that, so we'll just change this back to no, then we'll press OK. So now we will be able to properly generate object files. If I go back to my folder, I don't see any object files generated, right? Only CPP files. In debug we don't see any .obj file extensions, right? Now I'll compile this alone, edition.cpp, and go back to the folder. See, an edition.object file is created, right? We got an edition.object file. That means our code is successfully converted to binary code. We'll open the file and see what is there inside. I'm using Sublime Text for that. See, this is the binary code which got converted from our code. This is our CPP file which have only 8 lines, and these statements are converted to this big machine code, right? So this is how the object files got created. Visual Studio has provided a way to see the assembly code instead of zeros and ones. We'll see how that happens. We just need to go to properties, go to C++, output files, and see assembly output, no listing. Just change to assembly only listing and press on OK. Let me compile this and see. It got compiled. I'll go to the location. We see a .asm file here, right? This is the assembly instructions which are given to the CPU, which can be read actually. I'm opening this assembly instructions. See, we can see here our addition function got called and we got values here. This is what assembly code looks like. Okay, the object file is created like this. I have pin down those locations for you. If you want to see the pre-processed file, do this following things. Go to property pages, C++ preprocessor, and activate that as yes. If you want to see the assembly code, make sure that you are selected assembly listing only. Post that, I recommend you to change them back to their original state. So that's all for this video. If you have any doubts and if you don't understand anything, just comment down below. If you want more content like this, please do subscribe. Thanks for watching.